So, good morning, everyone. I know that I'm the last one before we go to lunch, and everyone is super hungry. So am I. So, I'm here to talk, and I have created a different type of presentation for you guys. So, I'm going to be talking about AI, and just to clear some misconceptions. So, myself, I even had some misconceptions about AI. And when we think about AI, everyone believes that we still, or everyone thinks that it's an autonomous robot that is going to conquer the world and all this kind of thing. So I'm just going to go back to the basics, and I'm going to tell you about AI so everyone understands what it is. And I'm going to go through a couple of practical examples on how you could simply use AI for your benefit in your industry. So let's start with the big question. What is AI? So AI, or artificial intelligence, it's a complete field of study, pretty much what, physics or thermodynamics is for physics. So artificial intelligence has different topics. The first one is machine learning. I'm pretty sure that you have learned about it, or you listen about it. And if you go down another level, after machine learning, you will find deep learning. So we're going to talk about machine learning. I'll walk you through the deep learning, and then we're going to learn about discriminative models, generative AI, and large language models. Because right at the intersection between generative AI and LLMs, you find any of the products that you are familiar with. So the ChatGPT or Google Bard. So let's start talking about what machine learning is. So I'm pretty sure that you are familiar with, the fact that you need to train models and how to use them. So in the end, machine learning, it's a software or a program where you have input data, you can train that model, and that model is going to be able to make predictions based on data that hasn't seen before, okay? Isn't that cool? So let's put an example. Let's assume that you have a model, and you feed that model with Nike shoe sales data. So you are going to be able to ask that model to predict how well a new Adidas shoe is going to sell based on data that we have fed the system from Nike shoes data, okay? So you have that data, you use it to train the model, and then you have another similar product, and you can understand how well it's going to perform. So let's talk about different types of machine learning now that we understand what it is. So we have two types of machine learning, which is supervised learning models and unsupervised learning models. So the supervised learning models use labeled data, and I'm going to show you what it is in a second, while unsupervised learning models use unlabeled data. What does that mean? So let's put an example. So let's assume that we want to plot data for a restaurant that is, receiving orders, and we're going to just plot the total bill amount versus the tip amount that we receive for a given order. So here we have labeled data. As I said before, you can see that in blue we have orders that have been picked up, and in yellow you see orders that have been delivered. So once we plot all this data with this model, you are able to identify for the next order that you receive if the order is picked or delivered, where it's going to fall under the supervised learning model and the amount of tip that you are going to receive, if it's going to be higher or lower. If you compare it with an unsupervised learning model, here we don't have the labeled data. So you have raw data, and this unsupervised learning models normally trend to group data, or data falls into groups. So for instance here, we have plotted information about a potential employee joining a company versus the income that is going to receive. So in this example, if you hire a new person, you're going to be able to understand if they are going to be on the fast track or not, depending on where they fall. If they fall on the top left-hand side of the diagonal, they are going to be on the fast track, but if it goes on the lower side, they are not going to be on the fast track. So let's talk a little bit about the deep learning. So we started with artificial intelligence. I told you guys that we have the machine learning with the supervised learning models and unsupervised learning models, and we go another level down. Every time we're going down, the model is more sophisticated and it's able to perform better things. So deep learning, as you can see here, is a type of machine learning that uses artificial neural networks. And I'm pretty sure that you heard that concept before. So artificial neural networks are just a software representation of what the human brain is. We are imitating the human brain. So we have nodes and neurons, like the human brain. So the more layers the artificial neural network has, the more powerful it would be. So what is the applicability here? So artificial neural networks are used to create these models under deep learning model, where we normally have a small amount of labeled data, remember that we spoke before, and a big amount of unlabeled data. And let me give you an example. Let's assume that we are a bank. The bank is going to try to identify on their transactions if they are either tagged as fraudulent or not fraudulent. And the bank is going to be able to do this for 5% of the transactions, because maybe they don't have the time or the resources to do that. And once we have these, the system is going to make predictions on what it has learned from the 5% of the data, and it's going to create pseudo, let's say, predictions for the 95% of the remaining data. Okay? So, and it's going to be able to tag if those transactions are pseudo good or pseudo bad with a high level of likelihood. So the model is going to use that 5% of the data to make predictions on the other 95% of the data. Okay? Do we start seeing the applicability here? So going or continuing with the discriminative models, as you have seen, we've been talking all the time about, data, labels, and data points, and how do we classify them. And I'm going to show you what the artificial intelligence is doing in here. So let's put a very simple example, cats and dogs. Let's assume that you use your system with deep learning enabled features, and you can ask, or you want to ask your system if a new image is a cat or a dog. So the system is going to learn from the labels. In this case, it's not going to pay attention to the image itself, it's going to pay attention to the metadata. So if the image has been tagged as a dog, when you ask the system to give you a dog, it's going to take a look at the data, and it's going to generate it's going to provide you a dog. But when it comes to generative AI, which is what we are using and we are not aware of it every day, it's going to be something different. So we are not going to rely on the tags or these labels anymore. It's going to be based on the patterns that the system learns from the data that we have been feeding it. So again, going back to our cats and dogs example. For a cat and a dog, the system is going to analyze the images and is going to extract patterns, and is going to understand that every dog is going to have 4 legs, it's going to have 2 ears, it's going to have 1 tail, it eats a food dog and barks. Okay, so by the time you ask the system to generate a dog, the system is going to create something completely new based on the data that it has learned. So as you can see, the image on the right is something completely new, not based on what we had before. So how do you differentiate if you are using generative AI versus standard artificial intelligence? So it's not Gen AI if the output of your system it's a number or a classification, like fraud, not fraud, spam, not spam, or a probability. But it's generative AI if you prompt the system and the system is generating a new image, something completely new from what you requested, or an audio. You've seen, I'm pretty sure that you have tested any of those AI generators where you can create a song for someone, okay? So this is something that is generative AI. So in the end, generative AI is going to create something completely new based on the data that it was trained on. And there are plenty of different softwares available just for that. So in text-to-text, you have the Google Bard, the ChatGPT, but you have generative AI softwares for text-to-image, text-to-video, text-to-3D, or text-to-task. So I have just added some logos here that I'm pretty sure that you are familiar with. So we're getting into the final thing, and before we go into the practical example. So let's start talking about the large language models. So large language models, and this is what you guys normally use for ChatGPT or Google Bard, it's a software that it's pre-trained with an insane amount of data. So you can just fine-tune them for a specific purpose, because if you go to ChatGPT and you pretend to solve or resolve problems that you have for your day-to-day business, it's going to be completely impossible. So, for instance, let me give you a very simple example. You can have an LLM to represent a dog, and that dog can sit, come down, or stay, but then you can fine-tune that dog to convert it into a police dog, into a guide dog, or a hunting dog. This is after you train the system and you convert it into something really specific, okay? So, examples of LLMs. So we have LLMs for text classification, for question answering, document summarization, et cetera, but when you fine-tune them, you can use them for solving problems for the retail vertical, finance, healthcare, or entertainment. And just to give you a final example about this, let's assume that you are a hospital and you buy a license of, Google Bard, the Meta AI, or the Open AI systems, but then you can train that system with data that you have at the hospital. You can train that LLM with specific diagnosis data just to improve the diagnosis accuracy and be faster and more, and provide those diagnoses more reliable. So let's go to the test before we go to lunch. And what I did is I just installed a couple of plugins into ChatGPT. I installed a plugin that it's called seeds.aero, which is something that you can use you can do on your own. And for the purpose of this demonstration, I have used London, not Dublin, because it was difficult to find stuff in Dublin. But I'm saying, hey, I want to fly from Barcelona, where I live, to London on October 8th. Can you just give me some plane tickets? So ChatGPT is going to present me with a table of possible options, and it's going to give you the link directed to the website where you can buy those tickets. And you can just be more specific and say, hey, can you order them based on loyalty points, or can you order them based on pricing, or whatever. So you can do that. And I'm pretty sure that no one has tested that before. I'm using it right now. So after that, since we do venue mapping and we create digital twins, I'm interested to understand how the online ticket purchase flow would work in an environment like this, okay? So what I'm asking the system is, can you show me ticket options for a basketball match on the British League in the first week of October? And then the system tells me a few options. So you have the London Lions, the BBL official website, and the ticket vendors, okay? So then I'm happy about the result, and I'm telling the system, excellent, can you show me the best seats for a short person like me that doesn't want to sit in front of a tall person, okay? I'm trying to be more specific here. And obviously the system has started to tell me something very obvious. Hey, let's go to the first row of any section. That's pretty cool. Let's go to the courtside seats. Okay, cool. Let's go to the front rows of the lower bowl sections. Yeah, so these are general things, but the system is quite accurate in that regard. Okay, corner seats in lower sections, seats behind the team benches, or elevated sections. Okay, that's cool. Then, what I'm trying to say is, can you show me some seat views for any of the proposed options? And then the system says, unfortunately, I'm not able to do it, because sometimes I faced connectivity issues, sometimes I faced GDPR issues, whatever. So I said, okay, that's my turn then. Let's train the LLM a little bit with data that we own. So I'm going to use an abstract representation of an arena here. And here what I have is an overhead map of a particular basketball arena, where we can see the sections and the section names, and another one where we can see every individual seat of the arena. And I'm going to load this into ChatGPT. You can literally go and say, hey, just load this thing and add it to your memory stack. So by the time I do it, the system, it's intelligent enough to understand that I have uploaded 2 overhead images with a seating arrangement for a sports venue or an arena. That's pretty cool, just with, again, image analysis using generative AI. So, and yeah, I tell him, yeah, it's an overhead map for a basketball arena. It says thank you. And now what I'm going to do is I'm going to upload several seat views, okay? So I'm uploading this one, section F2, the N212, the E203, the 209, and the 105. And the system is going to be able to understand and correlate those images with the overhead maps that I uploaded before, okay? So once I have this in place, now I'm going to try to ask the system to be more specific and provide some answers for me, okay? So now the system has been able to identify and locate the sections with the overhead map, and the system will be able to describe every view based on what I'm asking. So again, I'm prompting the system and saying, can you show me the best seats if I want to be closer to the players? So now the system is going to take a look at it, and it's going to come back with 2 suggestions based on the images that I just uploaded. So section N05 and section F2. And it's going to compare them, and it's going to come back with a recommendation, okay? So in its opinion, F2 is the best option. So F2 is this one, and N05 was this one. So I said that I wanted to be close to the players. So the system is just providing that solution. In my opinion, is the good one, okay? So now I want to show, I'm asking the system to show the best seats in case of an evacuation, okay? So I'm paranoid, and I want to make sure that I'm close to a potential exit in case something happens. So the system is going to do the same. It's going to go through a comparison based on the overhead maps and the images that I just uploaded, and it's going to come with 2 solutions. So upper level sections, where we have 2 images, and corner sections. It's going to compare them, and it's going to it's going to prompt the pros and cons. And as a conclusion, it's going to present the section E203 as the solution. And that's one of the options, N212 and 203. So as you can see, the solution is quite accurate, because this one should be far from the action, so it's finding a compromise between the action and the evacuation plan. So with all those premises, now we can start applying these to our business. And as I said, we do venue mapping, and we do these to help organizations pre-selling their inventory either ahead of the opening or while they are selling tickets online on an online ticket purchase flow. What we have done is to try to convert a traditional online ticket purchase flow into a conversational ticket purchase flow. Okay, so I'm going to show you here a real case study for a group sales platform that we deployed in the US for an MLB team. So a group sales platform means that you can go and you can order up to 250 seats, and the system is going to try to sit them together in the same section or in adjacent sections. Okay, so instead of just going and doing it the traditional way, we're going to go the conversational AI way, where I'm going to prompt the system, and I'm going to ask the system to get 50 tickets with a minimum price. So we're going to give the system a range, 20 and 80 bucks, and next to each other. So the system is going to respond with something like this. Let me look for these 50 tickets. And as you can see on the left-hand side, we are prompting the system. You can see it over there. And by the time I click on Add Best Seats, it's going to find, or it's going to use artificial intelligence to gather the best seats available for that particular request. So it's going to come back and say that he found the 50 seats in section 228 with the average price of 22, and he's asking me if I want to add them to the basket. But before I do that, it's going to show me the seats on a 3D map. Okay? So again, we do those maps and we integrate them here, but the intelligence or the artificial intelligence is going to add them into the basket. So here the magic happens on the next step. So the first part is an excuse to reduce friction. And I know that this is something that everyone is looking here, how to reduce friction, especially for people that they are not used to interact with computers or phones, or they just want to do it with their voice, or they just want to text the system. So we're going to go straight to the card here, and we're going to be able to play with the different options that are going to create an upsell for that. Okay, so having the seats is fine, but now The good thing is if you go and you click on the hat, or if you click on the loaded value, maybe the average transaction is going to be multiplied by 2 or 2.3, or the average that we find is 2.6 times what the original transaction was. And then you can click on this and add it to the basket and proceed to checkout. Again, this is just an example on how artificial intelligence can help from the very beginning, just speeding up your processes and creating an online ticket purchase flow that makes sense. So I just wanted to show something different, a couple of practical examples. And if you want to learn more, I'm here. I'm happy to connect. Drop me an email. Let's connect on LinkedIn. And I don't know. I don't know if we have time for questions. Otherwise, we'll just go and have lunch. And as I said, happy to take any conversations offline. Thank you very much.